Hello my dear students, welcome back to Learn Physics. In today's video, we are continuing with our kinematics portion. Last class we learned about the graph. In that we learned about uniform motion and uniformly accelerated motion. In today's video, we are continuing with the graph portion only, but here first the object is going under retardation and then it is retardation and then acceleration. Okay, first retardation then acceleration. Which kind of motion it will be? Yes, if we are throwing an object in the upward direction, what will happen? Throwing, it has some initial velocity, right? And when we are throwing, it has some initial velocity. While reaching to the maximum height, velocity is equal to 0. Then what will be the acceleration at that time? Acceleration will be 9.8 meter per second square only. Since we are considering the velocity along the upward direction as negative, so here acceleration will be negative. And here velocity is moving with an initial velocity. When it is moving upward direction, initial velocity will be there. So u is present and v is equal to 0. So velocity is decreasing with respect to time. That's why acceleration is considered as negative acceleration. And when after reaching to the maximum height, it will start moving downward direction. There, initial velocity will be equal to 0, final velocity will be present. That is, velocity is increasing with respect to time, so acceleration will be a positive value. And during this time, how this velocity equation of motion will be? So in the upward direction, when we are considering the upward direction, v is equal to u plus at, therefore u equals at, that t equals u by a. Right? Then when we are considering the here s is equal to ut plus half at square. This will be the displacement equation. Right? The same way, so here displacement is a parabolic equation. This is only in the upward direction. The same way in downward direction also we can represent the values. What will be the maximum height that the object will be reaching? How we will be finding out? As I say, v square minus u square equal 2as. Therefore, u square equals 2as. S is equal to u square by 2a. This will be the equation to find out the displacement. Now, here we are discussing about the graphs, right? So here, in this case, how we will be representing the displacement time, velocity time and acceleration time graphs. Okay, first I am going to consider about the acceleration time graph. Acceleration time graph will be here. Time is along the x-axis and acceleration along the y-axis. Here we know it is negative acceleration and positive acceleration is there. So we can draw like this. Negative acceleration will be here and positive acceleration will be here. That is, both will be 9.8 meter per second square. So this will be the shape of the graph. Okay, then if I am considering the velocity time graph, velocity is decreasing with respect to time, and after reaching to the 0 position, then velocity is slowly increasing, right? So velocity time graph will be here. Initial velocity is present and it is decreasing, coming to 0 at a particular point. Velocity is coming to 0 and then going in the positive direction. It's increasing with respect to time. So the velocity time graph will look like this. Next is displacement time graph. When we are representing the displacement time graph, see here displacement is along the y-axis and time along the x-axis. The graph will be displacement increasing, reaching to the maximum height and then decreasing. Here when we are considering the initial position, what will be tan theta here? Tan theta will give you the slope. Slope of the graph can find out with the help of the tan theta, or can find out with the help of dy by dx. Any one. Okay, tan theta, how we are opposite side divided by adjacent side. So this is theta 1, and when you are considering here, this tan theta will be like this. Okay, so theta here, theta 1, this is tan theta 2. Okay, this is how we will be finding out the velocity. Clear? So this is acceleration time graph and velocity time graph. From velocity time graph you can find out acceleration by finding out the slope of the graph will give you acceleration, and we can find out the displacement of the object from the area under the graph. Okay, from displacement time graph you can find out the velocity. Clear? So velocity, this will be the maximum height. Okay, maximum height position will be here, and then here no slope at all, so velocity is equal to 0 at the maximum height. Clear? So now we are going to do some numerical relating to this. Acceleration time graph of a particle moving in a straight line is as shown figure. Velocity of the particle at time t equals 0 is 2 meter per second. Find the velocity at the end of 4th second. T equals 4 seconds. We need to find out the velocity. So initially velocity is 2 meter per second. The graph is given like this. Here it is t in second, acceleration in meter per second square, and here 0 to 4. So it is increasing and then decreasing. Here it is 4. Okay, acceleration time graph is given. Initially it has velocity v equals 2 meter per second square and 2 meter per second. We need to find out the velocity at time t equals 4 seconds. How can we find out from the acceleration time graph? How can we find out the velocity? Area under the graph will give you velocity. So what will be the velocity at this region? How can we find out? Velocity equals area under the graph. Area under the graph, so it is like a triangle. So half into base is 4 into height is this much, it is 4. So here you will get it as 8 meter per second square. This is the velocity. But here initially it is not starting with velocity 0, right? It has 2 meter per second velocity was there. So here change in velocity only, we are getting change in velocity over here, that is 4 Vt minus V0, that is equal to 8 meter per second. Therefore Vt will be equal to 8 plus 2, that is 10 meter per second. Clear? This is how we will find out. Next question is, the acceleration versus time graph of a particle moving along a straight line as shown in figure. Draw the respective velocity time graph. So acceleration time graph is given over here. This is acceleration time graph. Acceleration, here values are given 0, 2, 4 and 6. Here it is 2 like this and 4 to 6 like this. Okay, here it is minus 2. Here it is minus 4. We need to find out velocity time graph v equals 0 at time t equals 0. Okay, so velocity time graph we need to draw. So here acceleration is constant with respect to time. That means it is under uniform velocity. Uniform velocity means it will be a straight line graph. Velocity. Then it is remaining constant. Till 2 seconds it is remaining constant 2. So here 2, 4, 6. Till 4. Initially it is velocity is equal to 0 and then it is coming till 2 seconds. From acceleration time graph, how we can find out the velocity? Velocity equals area under the graph. Therefore 2 into 2, that is equal to 4 meter per second. Okay, so here velocity is 4 meter per second. It will be at 2 seconds it is reaching till 4 seconds. Then next is acceleration is 0. Then it is moving with a constant velocity till 4 seconds. Then 4 to 6 again decreasing. Negative acceleration. Negative acceleration is velocity is decreasing. Velocity decreasing, how much it is decreasing? Here velocity equals 2 into minus 4. That is 2 into 4, it is 8. Negative. So here velocity is coming to 8. So here 8 meter per second only we got it as velocity here. In here, but initially it was having velocity 4. From there 8 second. So from 4 it will be reaching to 0 and then will be moving to 4 second in the downward direction. So minus 4. So from 4 it will be coming to 0. That is minus 6 seconds. It will be coming till minus 4 second. So together it is 8 meter per second velocity. So the graph will go like this. Clear? So otherwise you can consider it as it has initial velocity v equals u plus at. This formula you can substitute and find out the velocity. Then also you will be getting in the same manner 4 minus 8, that will be equal to minus 4 meter per second. So it is negative direction. Clear? So from the graph you should identify which type of graph it will be. Uniform acceleration, so velocity is uniform acceleration means it is velocity is increasing with regularly with respect to time, right? So it is moving with respect to time. The velocity time graph will be a straight line like this, and here also velocity time graph will be a straight line which is decreasing. Next question is, a car accelerates from rest at a constant rate alpha for some time, after which it decelerates at a constant rate beta to come to rest. If the total time elapsed is t seconds, then evaluate the maximum velocity reached and the total distance travelled. So here the car is accelerating from rest. So initially it was at rest and then it is moving with particular velocity. Accelerating at a constant rate, acceleration is given as alpha for some time. And then it decelerate at a constant rate beta. Then final velocity become equal to 0 and acceleration is beta, decreasing with respect to time. Then if the total time elapsed is t seconds, evaluate maximum velocity reached. Maximum velocity reached and total distance travelled. Total distance travelled. Okay, these are the things which you need to find out. Maximum acceleration is initially acceleration, second case it is deceleration. So first we can draw a velocity time graph for that. Here it is velocity, time graph, uniform acceleration. So velocity is increasing with respect to time at a particular time t1 and then it is decreasing, right? And at a rate another slope beta and it is at t2. It is reaching to the maximum velocity here. This is the maximum velocity position. Okay, I am representing it as Vmax. Clear? In this Vmax here, what will be the time taken over here at acceleration till t1 when I am considering? So acceleration equals that's velocity, change in velocity divided by time. Therefore alpha equals Vmax divided by t1. Therefore t1 equals Vmax divided by alpha. Next is till t2. Same way t2 will be equal to Vmax divided by beta, right? Here the total time taken, we had taken the total time taken. It's given in the question as it took t seconds, right? Therefore t1 plus t2 will be equal to Vmax by alpha plus Vmax by beta. So here we can find out Vmax equal into 1 by alpha plus 1 by beta, that is Vmax into alpha plus beta divided by alpha beta. Hence we can write down here t equals, okay, t already given, Vmax will be equal to alpha beta t divided by alpha plus beta. This will be the maximum velocity because in the question it is given it took t seconds. So maximum velocity will be equal to alpha beta t divided by alpha plus beta. Next we need to find out the total distance covered. So from velocity time graph, how we can find out the total distance? The area under the graph will give you total distance. So here we got the maximum value as alpha beta t divided by alpha plus beta. So here total distance covered total distance will be equal to half into area under the graph, half into T1 plus T2, that is T base into height is this one, alpha beta T divided by alpha plus beta. Okay, so half alpha beta T square divided by alpha plus beta. This will be the total distance covered. Okay, so this is total distance and maximum velocity. Clear, children? So these are some of the questions from relating to that graphs and all. So you can do some more numericals relating to that. So while we are doing the revision exercise questions, we will do that, and some introductory exercise questions also it's given. We will do it in the next class. So I hope today's video is useful for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.